Welcome everyone, and really glad to be back doing a session for Bangladesh. There is a very big problem here. I keep doing sessions for you, Asan, but I never go there, which needs to be changed. So some point in time, I need to visit Bangladesh. This is on my list, and with the end of the pandemic, this is something that's definitely required. So we'll try to see this in the future, in the near future, I hope. Okay, so let's talk about
2014. We are arranging on second Saturday on prem. So I hope you can able to manage time to attend the session. Thank you very much for your interest to coming in the Bangladesh. You are always welcome.
I'll definitely do that. This is a country that I've been doing so many sessions to, and it's something that I've seen photos and things, and I would like to visit at some point in time. So yes, let's hope that this is possible. Anyway, you probably know my cat. This is my crazy cat that has been around. I don't see her now, but she's probably sleeping because on the other room there's like the heating and things. So she's probably there, so that's okay. So this time we'll probably not see her. And this is me. So my name is André Melancia. I usually do these kind of crazy sessions, a lot of these for Bangladesh. And yes, so this time we're going to do a session which is slightly different from the others, but it's still a continuation from a series of sessions that we've been doing. So we started with talking about things about machine learning, what was machine learning and how to use it in Azure ML. But we continued to talk a bit more about this, a bit more detailed. And we actually have a third session, so we continued on to this. So the names just are different, but it's a continuation. So we talked a bit more and a bit more. And last time I was here, we talked about creating a new ML project so that we can actually use it, etc., in some application. This was fairly easy. But the previous times we mostly talked about using things like graphical interface to do machine learning or the AutoML. I didn't really discuss much about the Python ways, okay? And Rifat just before was actually showing us, answering a question that there was a possibility of using Python, using R to do machine learning. And in reality, his suggestion was the same as I would say. It's always better to use Python than R because there is a bigger community that will support it. But both of these languages are quite awful. Okay, and yes, I'm doing a session just now on Python and I'm saying it's terrible. Yes, all of the tab things and space things, any small mistake will make it not work. But think about this from a machine learning perspective. Most of the code for machine learning is actually very straight, so it doesn't really require any indentation or anything like that. It just works really well. And for the code that we actually use, it's just calling functions from machine learning libraries, and it's not going to be that difficult. So it will just work. It will be easy. It will look familiar like any other programming language, maybe with one or two crazy things like weird magic things. But yes, so today we're going to talk about slithering through machine learning with Python. So yes, we had the Terminator theme, but now Terminator meets Harry Potter, and we have the sorting hat, which actually tells you that you're going to slither your way into Python and start to talk the language of snakes. Okay, so if you're not familiar with Python, good way to start. And honestly, this is not difficult. It's very easy to declare a variable because all you have to do is to use it, and there isn't any special science to use Python. Okay, so of course you can install it on your computer on Windows, Linux, etc. Very easy to do. I'm actually going to show you how to use this in Azure ML Workspace. Azure ML Workspace can be free. Up to a certain point, you can get the free Azure account for a while. If you are a student, you can also get that for free. But in any case, we'll have a look at how this works. Okay, so I have very few slides before we begin. Okay, very few, because most of these are from the previous session, so it's easy. But just to mention one thing, so last week we had an event in Portugal which joined Global AI Bootcamp, which you are having in Bangladesh right now. And last week you had Global Power Platform Bootcamp also in Bangladesh. Hassan organized both of these, and before Hassan actually joined Global Power Platform Bootcamp in Bangladesh, he actually joined us for a keynote in our event in Lisbon, which was really nice to be able to talk a bit about communities, etc. So remember that these initiatives, it's really great to have local initiatives. I really hope that we can get back to in-person events soon, but these remote events, the most important part is not just to do the sessions, because anyone can record sessions, but it's actually to interact between different communities all over the world. I can do sessions for the other side of the world, can do sessions for us, and we share knowledge. So these kind of global initiatives are very nice in that sense. However, we also need to have in-person events, and they will have food and all of those things. Okay, so because we are using Teams, it is possible to use AI subtitles, and all of these are done by Skynet so that they will manipulate us. No, I'm kidding. But you can use subtitles if you'd like. But if you are watching this later on YouTube also has one of those subtitle things, so you'll probably be able to watch the subtitles as well. If not, you can do cognitive services, and even Windows nowadays has a way for you to see subtitles for all of the things that you are seeing. So all of these technologies are available everywhere. So if you feel like you need subtitles to translate this to a different language, you are welcome to try. Okay, so very multiple options. Okay, and of course, if you have any questions, feel free to ask. Okay, very happy to ask questions. I know you are in many platforms watching this at this moment, but Hassan has been, compiling these in all of these events and asking them to the speaker in real time. So very, very nice. And we'll have any questions and just ask. I'll be happy to help. Okay, so anyway, this slide was from before. I'm going to repeat 2 or 3 slides from before just to recap. Okay, and before we were actually talking about machine learning. This is a limousine cow, which shows you what machine learning shouldn't be, because there's probably 1 or 2 other cows somewhere in the middle, but this indeed happens. What's missing here? You need to, of course, set limits to the sizes of these things. How do you do that? No idea. I have no idea what technology they are using for this. I just got it from the internet. This is how people get things. Okay, so machine learning. So we had some introduction about machine learning before. Algorithms like regression are very simple, so you can have linear regression, which is just a line, so you detect things in a continuous environment, so you can do things like biology, economics. It's easy enough. Most of these will not be a line, however, although you can simplify it to a line. Most of these will look something like this, and the machine learning is actually doing what you see changing at this moment. The line is trying to calculate the closest option to all of those points, and this is gradual. It can take hours, months, years. Not years, hopefully not. Sometimes it just takes seconds. Okay, and you also have, this is 2D, the bottom one is actually 3D, 4D, 5D, so you can actually have a lot of different results, in fact. Okay, now one of the things that's important is that with regression, if you have margins of error, these are like these dots here. Okay, so these dots that you see here are the distance between what's actually the reality of the reality, and sorry about the repetition, and the actual prediction. In this case it's a plane, but it could be a line. So for instance, if you have this number here, the one that's most on top, from there to the line there is going to be a distance. Okay, and that distance is your error. Okay, and you take all of that error and then you do a lot of different options with the error, some metrics. One of them is root mean squared error, probably one of the most useful ones, because the result of that will still be in the same unit of measure that you get for the y-axis. In this case it's temperature, so that's root mean squared error between that dot over there and this. It's an individual error also in degrees Celsius, but if you mix them all together in root mean squared error, the whole thing will also be in Celsius as well, so you can compare it. Okay, and in that case the smallest one is the best one. Okay, however, so a few examples here. So the distance again, but on 2D. So all of this are the errors, and the smallest you have them, the better it is. Obviously, this one is bad, but then you have underfitting, which is just a line which gives you a lot of error. This is probably the best, which reduces the error, but this one is so overfitted that if you add a new value, let's say where I have the mouse here, which will work fine, or even here accidentally, but if you put it here, it will have a huge margin of error. Okay, so the distance between top and bottom, so from here all the way down here, so this distance would be huge, but here it would be just very close to the line, so it will work okay. So overfitted is spending a lot of hours having a huge thing like this being calculated, so a huge in most cases might be like a polynomial like this. You calculate it more and more and more with a lot of different additions in the polynomial, and then in the end you can only calculate the things correctly for the data you already had. So you want to calculate it for future data that you don't expect, and in this case the good fit is this one in the middle, which spends an average time processing, so not very little, not very much, but an average time processing, and it will find the best results for future for future points that you don't know anything about, but you ask about them and they will give you the prediction, and the prediction hopefully will be good. Okay, so anyway, a lot of statistics monsters. If you try to do the average of this, this is what you get, okay? And I drew the line myself, so it's probably wrong, but there's a lot of examples like this on the internet. Be careful with statistics because they will fool you, okay? Please be careful. In many cases, you can have a dot on top and a dot in the bottom. They will annul themselves, and suddenly you just have a line. So it's not a good example of how to do machine learning. Machine learning needs to be a bit more consistent, and especially you need to understand your data. Okay, so in this case you just see a dinosaur, but it doesn't really help you in terms of understanding the reality of data, because the first average will look like this, which makes no sense. Okay. Anyway, besides regression, we also have classification. So two class models are classification. Here it's logistic regression, which is a special case of classification. It does say regression, but it's still classification. So it gives you a result of A and B, yes or no, true or false, something like that. But you can also have classifying multi-class models, which are 3, 4, 5 models. In this case, you can have a very simple algorithm for multi-class, which will give you the results. But if you are just having two classes, this one is best. Okay, so anyway, k-means is also another algorithm, so you can have aggregation of things by topics, and in this case you usually have 2 or more dimensions. It can be 3D, and 2 or more dimensions can be things like mixing people that buy this with people that buy something else, and then with people that buy even something else on a 3D level, and then try to see where they match and have these clusters. Okay, very easy to do. A lot of people use this kind of thing, so very easy to try, and the algorithm is very simple, and it's from the early 70s, so very, very old. Okay, but they do have optimizations on it. So this is where we're going now. So remember about machine learning, just recapping very, very quickly, and then we need to do the actual demos. So if you do it graphically, the normal scenario is get data, divide data into 2 parts, the training and the testing, and then you do the actual training, and then from here you do you get the model that comes out, which is the magical results, you know, all of the Harry Potter magical results. So it's like a small thing, a small potion, a small drip of potion that will have all of the results from petabytes of data into a small few kilobytes, and that model, which can be stored as a file in most cases, used in a mobile application, etc., that could be used for scoring the model. So scoring is doing prediction or inference. It's the same thing. So it's calculating the a possible result, and then you take the remaining data for testing, like 30%, 20%, and then you calculate the result of that, and then you evaluate if that is good or bad. So, okay, let's say it's classification, so yes or no, you might have an accuracy of 85%, 90%. That means that they got it right. Okay, so I'm not going to spend that much time on this because we had previous videos to talk about this. Just follow the sequence, the series of videos. But let's actually talk about machine learning. So remember, this from a computer's point of view is really a sandwich. It checks every box. No one told you it had to be horizontal. Okay, so remember that you have to be careful what you expect to tell the computer, and especially now the AI bots. Be careful because you might get the wrong results, and the bots is very innocent. They didn't do anything wrong. Okay, so machine learning cheat sheet algorithm. Very interesting as well. This is mostly for graphical stuff, but let's talk about Python. So in Python, this is very easy. One last slide for completeness. This is the same as the other ones, so this will just be in the video, but I'll skip it. A lot of technologies that can use this. You can just use Python directly, or in SQL Server, or in Azure Machine Learning, or in Spark, or in Synapse with Spark inside, or in Databricks with Spark inside as well. Anything is okay, but just use it. It's interesting. Okay, no, the magic is in the libraries. The language is awful. Magic is in the libraries. Let's have a look at some Python codes. Okay, so let's have a look at a machine learning session with a slithering demo. Okay, and first of all, you start with the Azure portal. If you don't have an Azure account, go to azure.com/free, and you will actually be able to where you will actually be able to use this. So real life example where you can use each algorithm, sure, of course. So very quickly, let's go back for a bit. Okay, so clustering. If you have multiple, let's say shopping trends. Okay, some people buy this, some people buy that. Where do they match? Okay, so I like to buy this kind of product, that kind of product, that kind of product, and clustering will help. Also, there's also algorithms for association that do these kind of things. This is not the only one. This is specifically clustering, but there's groups that you can understand and mix two different realities and see where they match. And sometimes they match in 2D. If you have three realities there, it's 3D, 4D, 5D, so that can work. Okay, so going back for a regression, if it is going back for classification, if it is two-class classification, a true or false might be something like a bank loan. Okay, so you feed in all of the information about the person, what's your job, how much do you make, are you married, etc., and then in the end they will give you a result which is between 0 and 100%. So this is important to know, and that result, if it is closer to 0, that could be a yes or a no, depends, and the other one can be a no or a yes, depends. Okay, so there's no right one to say yes or no. Okay, it will depend on the data that you have, but in any case, there was, let's say, assume 50% in this case. If it is less, that will be, let's say, a no. If it is more than 50%, that would be a yes for the bank loan. Okay, doesn't have to be on the 50% threshold. You can adjust it to higher or lower. It's entirely up to you. Okay, and it can be the other way around. So yes can be 0%. So there's nothing wrong with that. Now, if you have more than two classes, let's say that you have a model that detects fruits. Okay, so you have a conveyor belt and you pass fruit or any other, industrial product. You take a photo, and this will detect A, this will detect B, this will detect C. So bananas, apples, and oranges, or something like that. Okay, so in that case, you need a 3-class model, 4-class model, etc. So there are models for different things, and these can be just text. This can be, normal database, text in a table, or this can be images or even sounds or something like that. Okay, so the thing will vary. Although, of course, for images, you'll probably use, deep learning on a lot of different things, but some of these will still be integrated in multi-class classification. Okay, an example of that is the custom vision from Cognitive Services, from Azure Cognitive Services. Okay, and last but not least, regression. You can calculate anything. So technically, up to 1 or 2 days in the future, you can calculate the weather. You can calculate. Well, you need a lot more than this to calculate the weather. It's one of the most difficult ones to do. But you can calculate things that are things like biology or something like that. Some trends. So things are expected to go up and down. Let's say a stock in economics. By the way, don't trust anything that relates to the stock market, because it's not math. It's human panic. Okay, so the stocks will go up and down, and they have a trend to go much more down quickly than up. So you're not going to make any money out of this. You're going to spend money. And economics, if there's a panic, they go all the way down and you lose money. So please be careful. Don't use machine learning for economics. Okay, so I think that helps a bit. There are more algorithms, but I will skip that for now. Okay. So you also have let me just write this here. So aka.ms/ ML cheat sheets. Okay, this will give you some examples of some of the others and how they work, but most of these are used only for the graphical stuff. You can use them in Python, you can force and use them in Python, but it's more for the graphical stuff. In Python, you have other algorithms as well. Okay, so let's go back to the demos. Okay, oh, one back. Okay, let's go back to the demos. And in this case, you start with the Azure portal. I mentioned that you can start with a plus sign and then create an Azure machine learning portal. So you go here, create one. This is very easy. So you start with this one. Let me shrink this. Oh, I have my cat here finally. She's probably hungry. Okay, so you start with machine learning and then you create a workspace name, let's say Andy ML, for instance, and then all the rest is automatic. You do need a resource group, so I've created a resource group already called Skynet will take over the world. All of the rest is default. You say review, create, you create it. Very easy. And then you say create. It will fail, of course. There's a lot of things that I didn't fill in. But once you say create, you will be able to create it. Okay. And then you go here for machine learning. Okay. And you look at all of the machine learning, Azure machine learning here. And in this one, I of course have my NDML machine learning. I've created all of this before because this takes hours to calculate. Okay, not this takes a minute, but you know, all the actual machine learning, it takes hours. So I'm not going to waste time in the session actually doing that. Of course, I'm just going to show you things. So from here, you can actually go either to this address or this one. It's the same. Okay, click on this and jump to the machine learning studio, which I already have open. And this is the first page. Okay, so this is the first page of Azure Machine Learning Studio, and you have home, and you have three ways of doing things. So you have the AutoML, which we talked about before. You just feed it some data sets. You can say create a data set from a list of previously created. Diabetes is one, and then you follow by specifying you specify what kind of column you want to calculate, which is the Y, and then say something like this, and then you say, oh, is it classification, regression, or some of the other ones? In this case, it would be regression. You would say yes, and then it will calculate something. Okay, I'm going to cancel it. I'm not going to use it. I'm going to use Python on the notebooks. But just to show you Designer, so you can select any of the examples from the samples here. Okay, I had to create one for yesterday. Okay, something like that. Actually, not yesterday, but yeah, actually yesterday. I did a hacking session for AI. So anyway, you can drag and drop things from the left to the right. This is literally something you can just drag and drop from the left. You configure a few things like double click 70% here instead of 50 like they had it, and in the train model all you have to do, because this is the census income one, which at the end gives you a result of how many people, how much money they make. If it's more or less than a certain value, you have a column name of income, you add the column name. So edit column, you include the column. Now this is very simple. So this is just a data set, normal table. Okay, you can even preview the data if you want to. This is normal tables that you have here. Okay, so very easy. Some income column, that's the one you want to calculate, and then once you have this kind of thing, you choose the algorithm. In this case, it's a 2-class something, doesn't really matter what it is, and it will calculate things, score the model, and then you evaluate how good it is doing. So very easy. Okay, now we're going to try exactly all this but with codes. Okay, so focus on this. First you get the data, then you split the data, then you decide on the algorithm and configure it. So if you double click this, I didn't change anything, but you have some configuration. These are called parameters or hyperparameters of the actual algorithm that you use in the training. Okay, and then you have a box that says train model. In this case, it's just calling a function in Python. We'll see how this works. By the way, all that you see here in the end, if you look at the insides of this, if you go to the storage accounts and look at the insides of this actually generates Python code that you can reuse as well. So if you're not, it is a bit complicated to use it like that. So, okay, it's very complex, but technically, if you like you have something very complex like this, but you want to add something else, you can fully write it in Python and take it somewhere else. Or if you prefer, you can actually add a box like this along the way that does R language or does Python language along the way. You can even have boxes that say SQL, okay, so have no idea where they are. If you search on top for this, you have a box that transforms things in a SQL way, apply SQL transformation, okay? So if you get the data initially, you can say, oh, I just want select field 1, 2, 3. So if you are familiar with SQL, use the apply SQL transformation. If you are more familiar with that, then Python or any other box that you see here, nothing wrong with that, okay? But in any case, the insides of this are actually Python. Now, once you train the model, you take that variable, and in the end, all of these arrows are going to be variables, okay? You take these arrows and go all the way down for this, okay? Now, I'm going to open a notebook. There's a lot of notebooks that are available here, okay? Nowadays, there's something called version 2 of the SDK, okay? And that version 2, so you start with the notebooks, you have users and yourself, okay? I already have some things here because you need to clone them. Let me just close this notebook thing here. So I'm still on notebook, okay? But let's go for samples. And on samples, you have a lot of things. SDK1, I will show you one example very quickly with the remaining time. And I will have SDK2. So SDK2, you have tutorials, okay? So Azure ML in a day is probably the best one. Very simple, okay? So what I do is I take Azure ML in a day, so the whole library of things, because the media thing that you see here is actually a lot of images to do explanation of what you need to do, okay? So, you know, like the instructions on how to do it. So don't copy just the notebook. This is a Jupyter notebook, or Jupyter. Some people say Jupyter, but Jupyter notebook, so IPyNB, okay, Jupyter notebook, but you need to clone the whole directory. You can clone the whole tutorial or the whole SDK if you want to. Nothing wrong with that. But in this case, I'm just going to clone this one. So you go here and say clone, say my user. So select my user here, and that will actually already cloned it. So I've ran this already. Okay, I've run this already. So I'm going to clone that one, and from SDK1, I'm actually going to clone tutorials of image classification and NIST. So the other one will be, data, which is actually from Excel, okay? First one, I think, is from Excel, which is tabular data, very simple, okay? The second one is graphical stuff, so digits, okay? So let's try it out. So Azure ML in a day, let's get started. This is version 2 of the SDK, so the recent stuff, but the old stuff still works, nothing wrong with that, okay? So recent version of the SDK. So all of these was created when I started the actual notebook, but let's open the notebook. Now I'm going to shrink this as much as I can so that we can see as much as I can. So what we have here is I have a VM running. Okay, so if it's not running, you can go here and have it run. So how do you do that? Well, you go here to, let's show you this. You go here to, all of these are three types of things that you can run. These are assets, so you have your data sets, so you can find your tables and your contents from here, okay? So jobs are the things that you actually run, okay? So when you ask to run the notebook, when you ask to run AutoML or the designer, they will run jobs here. Components are just things that you can add. Pipelines are the graphical stuff, so the one that you see graphical, you can also get that as code, so pipelines as code as well, so they will show up here. Environments are, I'll show you what environments are in a bit, and then you have models, which are the result, the magical result that comes out of this, okay? And endpoints are just for web services, okay? You connect to it via web service, you get some results, okay? Now in this case, I have a web service for census. Census, the ones with the one I just showed you, I got it from something else. And last time we were here, I showed you that you can actually see that you can test it. You can get values in the beginning and test them if they are correct. And then if you want to fake this, just add a whole bunch of 9s. This is score label 1% and less than 50. If you test it like this, more than 50 and 98%. So I just hacked this to be bigger, okay? And you can consume this in C#, in Python. So you have literally all the code already done for you. All you have to replace is the values. But this is consuming. This is the end. This is consuming, okay? But yes, it can be done. We'll ignore the rest of the endpoints for now. We'll focus on the codes, okay? So you can also play around with computes. Compute, you have VMs for compute, which is the first one. So this is where you run your notebooks. You can run them on your computer to be cheaper if you want to, but you need the libraries installed. That's easy. And you have compute clusters to run things as well. So either one, This might need to be created by you, but it's easy. Plus sign, specify size. They will actually give you the instructions in the notebook. So very, very easy. We actually saw this the last time, so it's actually very easy. Now let's try Azure ML in a day. So this is the first notebook. Okay, remember that if you are in the samples, you cannot make changes. You have to clone them first. You have to go here and use the clone, actually the directory. So let's say clone or something. So right click 3 dots. It doesn't fit here. It doesn't fit here. Okay, so you can actually go here and say clone and then move it out to your own files. By the way, these files can be in source control if you want to, so you can put this in a Git repository. It's entirely up to you. Okay, so anyway, you need to read all of this. I'm not going to do that now. I'm lazy. Okay, so when you run it, you need to click on a button to run it. So first of all, give me a second. Let me shrink this. Let me actually shrink this as well. I don't need it. Okay, and now I have a whole bunch of buttons. So restart, stop, run, and run everything. So clear everything and run. I'm not going to do any of those because that will destroy the work that we've done already. Select the compute cluster that you need to run, and especially select the Python version. Okay, so SDK2 needs Python 3.10. Old version, so version 1 requires 3.8. Okay, it doesn't work on 3.10. Easy enough. You can try R if you'd like. So there's a limited support for R because people are not using it that much. But if you use other things like PyTorch and TensorFlow, etc., and a few others, you can actually try some different versions. So these are different environments. You can fix your environment yourself by adding things at the beginning. So calling exclamation mark pip install something, which is the installer for Python, but that's okay. You can say, let's say you add a new bit of code. I'm not going to do that now, but you can say pip install something. Okay, no idea what it can be, but scikit learn, I think it's how you call it like this, I'm not sure, but if it's not like this, it's very similar. Okay, so the library, you can call it like this, very easy. Okay, the exclamation mark actually executes something in the command line. Okay, and if you're not familiar with the command line, you can go here and actually have a terminal and play around with the actual terminal. So when things are running, this is a Linux terminal going to that machine that's called VM1, and if you see this, these are literally the same things you have here on the left. Okay, so you can actually go inside of these and see things. You can do top, so you can see what's being used, etc. But I will just close this up. But you can monitor things, even old school, although there's graphical ways to do this. Okay, so anyway, how do you start with the SDK2? SDK1 is very similar. Okay, so how do you start with this? Well, you start by saying, hello, okay, import these libraries. Okay, from azure.ai.ml, you import the whole thing. Job done. Okay, and then some identity. You need identity so that you can authenticate yourself with this environment. Remember, this environment will store a lot of things like models, environments, generate web services, etc., and store your data. So you need to have authentication to this. Okay, it's important. Technically, if you just use Python, you don't need this, but the Azure Machine Learning interface is very nice for you to store all of that. Otherwise, you have to do it manually on your disk by adding files, and it's a lot of work to do this. Okay, so in this case, this is all done automatically for you, and it doesn't cost you anything. Well, it's minimum. It's just the storage. It's minimum. What you actually pay is to run the compute VMs, which technically, in that case, you can actually do from your computer and even be cheaper. Okay. So let's give it a try. So first of all, I get the credentials. Nothing happens here. I just get a credential. If you want to manually interact and authenticate yourself with a browser, you can also do that as well. So if you are running from your computer instead of from this interface, you can also do that as well. Then you need to fill this information. How do I get this information? This is blank. This is the only difference between version 1 and version 2. You have to fill this information. Very annoying. Okay. And where do you get this? Well, you go to your machine learning workspace, and you have here resource group. That's this name. Copy to clipboard. Subscription. You have the ID of the subscription. You copy it, and then you have the actual name of the thing, which is this one. You also copy that as well, and you put it on the other side. This is actually needed so that the libraries will understand who they are talking to. Okay, very, very important. Okay, so having said that, you register, and nothing actually happens, so there's no results here, so this is okay. And then, by the way, just listen to the instructions. These are easy. Okay, I'm going to skip the instructions, but it's very easy. And then from here, all you have to do is to create a compute cluster. Now this CPU cluster is the same that we had this already. Okay, so it's already been created. So you try CPU cluster is like getting the cluster. If it works, they say you already have a cluster. So in this case, actually they created it. But if I ran this again, they say you already have a cluster with this name, we'll reuse it. Okay. If you don't have a cluster, which is what happens in the beginning, you go and literally create a cluster. How do you create a cluster? Very difficult. One line of code, which is broken down for you to help, but basically it's just calling a function called AML computes. You say name of the thing is equal to that name that you had before, so just give it a name, whatever you want. Size, this is the size of a normal virtual machine in Azure. So when you are creating a virtual machine in Azure, just check the website and the documentation for sizes. Any size is okay, very easy to create. Minimum and maximum instances, very important. So let me go into this and show you. Okay, so minimum and maximum is important because if I'm creating a normal VM, you just start it or stop it. So very easy. So you can select it and then start it and stop it. However, if you choose clusters here, you need a minimum and maximum because you know they will always be kind of active, okay, and they will actually spend a bit of money in load balancing, etc. So if you don't want it, you can just delete it. Okay, that will be cheaper. I had that bad experience myself, so it will cost money in load balancers. So just kill the clusters if you're not using them. You can do code like that, just a line of code to say get rid of it, okay, and then you create it when you need it. Actually, because they are turned off, in terms of actually creating the definition takes 1 or 2 seconds. It's actually starting them because they are actively zero, so they are actively zero here, so they're not started. And provision nodes is 4, so when they start they actually spin up and you can click on it and see details, etc., but they are empty, okay, at this moment. So anyway, you create this with minimum 0, maximum 4. 0 is always important so that it will reduce to as much as possible. Idle time 3 minutes. It's whatever you want. Sometimes you have to stop in the middle of a script to get data, so it takes more. So your idle time needs to be defined. And then dedicated tier or low priority. Low priority is a spot instance that uses all of the cheap. It's like 80% cheaper in Azure and other clouds. But if Azure needs more machines, they will kill your machine immediately because there is a risk of killing it. So you are getting it very cheap, but if they need the hardware, they will kill it very quickly, okay? But this is good because if you use low priority, if this is not a critical process, use low priority, you save a lot of money, okay? You save 80 or 90% for this. Anyway, you print a saying, this will be created with compute size something, okay, and then say compute.begin create or update, the thing creates, and then you move on, you need to create a job. So first of all, you create dependencies, okay? And to create dependencies, use something called a conda file, okay? A conda file will actually add all of the dependencies, all of the libraries that you need. So this has all of these red things, but this is normal because the format of this is definitely not Python. This is just a write file, okay? So write file, if the first line says write file, what it actually does is to go to the disk under this directory, which is a variable here, and the conda something, and this will write to the disk this file. And that file is actually, so dependencies there, so here, and conda YML. So this will literally write this text, okay? It's just writing the exact text. So this runs in half a second, okay? And then you actually need to use it. So how do you use it? Very, very quickly. So you go here and from this, you say, okay, custom environment name. I'm going to create a custom environment, okay? And then you say environment is equal to this name, description something, doesn't really matter, tags something, it's bureaucracy, okay? And then conda file is that YAML file that you have here, so the one we just created on top. And then image, you can create an image of a machine, of a virtual machine that will be used in the cluster for each of the nodes, okay? In this case, it says open MPI something Ubuntu, whatever that means, okay? So yes, there's documentation about this somewhere if you really want to know, but by default, just use it, okay? And once you create this, so you go here, create or update, that creates the thing, and then they say, oh, it's registered. Great. Where is it? Okay, so you go here, let me just increase this. You go to environments. The curated environments come with Microsoft, so this is never the case, okay? So if you find it, it's not there, but if you go to custom environments, you have your environment right there. So I actually have two. So this one is the one, no, I think it's, okay, not sure which one is which. Okay, it's AML scikit-learn, okay. By the way, scikit-learn is one of the most famous libraries for machine learning, okay? It has a lot of options, and scikit-learn is, although it says learn, you know, it's, the machine learns, you learn as well how to use it, so start with that one, it's a good option, okay? So anyway, you create the environment, so you need to set up all of the libraries that will be available in the clusters when you run things, and then you need to create a job, okay? So first of all, you define a directory for the content. So main.py will actually be the code that you execute for the actual machine learning training. It can be on one or multiple nodes, okay? And what you actually do is you go here very, very easily, and you create the directories, etc., and then you add a file. I'm not going to go into a lot of details for this file, but the file is the main file, and this actually writes all of the things that you need to run machine learning training. So you start with the arguments. So arguments are like those hyperparameters that I mentioned. You start with the arguments, very easy, okay? And then you say start run, so very easy as well, okay? And you say logging, etc. So all of this is perfectly normal. You can also log metrics if you want to as well. By the way, you need to get the input data. Where's the input data? So here there is no information where the input data comes from, but down there, because this is just the script that you will execute later, okay? You need to fill those parameters when you're actually executing them, when you're calling this. Think of this as a function that runs on a separate server, okay? You need to call this with those parameters, okay? And then you need to split the data. So remember what we saw here. You get the data first. You need to split the data left and right, so a percentage, okay? And the percentage will be, the number is on top, but the number is like 50%, or I don't know what the number is. Default 25% for training, okay, for testing. So you get the training data and the testing data. You divide into two parts, okay? So 75% for training, 25% for that, unless you specify otherwise. And then you need to find out what you need one value, which is this default payment next month. It's probably the name of a column, okay? So this is the name of the column that you want to you know, predict with machine learning. So the Y train, you pop it out. Here you get the values for train as well. So Y train is the possible results, so it's only one column. The X train is all of the values, actually includes that column, but you don't need it, okay? And then the testing part, you do the exact same thing. Why? Because you have data sets like the one we saw before with all of the possible columns, and then the last column would be, let's say, default payments. In the Y training, which is the results that you want to calculate, you separate that column just so that you predict based on that column, and then the other part will be separate. Okay, so very, very easy to have all of these kind of things. Okay, so anyway, when you get this, so this is very easy, and all you have to do is to get some of the this is the boosting classifier, whatever algorithm that is, doesn't really matter, and then you add some parameters, and then you say fit. What's fit? It's actually doing the training. It's as simple as this. Doing machine learning training, which seems very complicated, it's just calling that, okay? And all you have to do is to give it the training data, which is the normal data. You have to give it that column which you are predicting, which is the Y train, and that will predict it, okay? That will train it, okay? Afterwards, and this is this part here for training, okay? Once you get the model, it comes out as a variable, and then you do the scoring, which is you take the test data and you try to figure out, is this a good model or not, and evaluate it. Now, that's the next part. So this prediction part that you see here is trying to do the scoring for the next box, okay? So you will try to, you just say CLF, which is the name of the classifier, or the name of the algorithm, and you say dot predicts, and you take X tests. Remember that this is not X train, this is now X tests, because it's the data that's the 25% that's left for you to test it. And then the Y predictions is the result. It's a column with all of the predictions for those 25%. Now, the next question you ask is, oh, how do I know which ones of this side match that one? Because it's line by line. Okay, so it's very optimized. They know exactly line 1 goes to line 1, line 2 goes to line 2. It's confusing if you are used to other things like C#, etc., because you don't do it like that. It's just magic. Okay, it's weird, but here you do it. First line is first line, second line is second line, and so on. Okay, so continuing, you need to figure out, is this a good thing? So by the way, you register the model so that the model will show up here in the model. So one of these, not sure which one. So this one, no, probably this one, no. I'm not sure which one it is, but it's probably, oh, it's AML Studio. This, no. Okay, maybe it's not there anymore, but I registered one of these. I'm not sure which one. Oh, I think it's credit defaults model. This is the one. I'm sorry, this is the one. Okay, so this generates this. Okay, you save the model, make sure the model is saved, etc. But at the same time, before you do that, there's something called a classification report, which you can understand if the if you predicted things correctly or not. Okay, so to see if things are all right, if things are not all right. So yeah, this is okay. So end run is just finishing all of the debugging, all of the logging, etc. It just tells you, oh, job done. Okay, so easy enough. No idea what this one does. Okay, honestly have no idea. Not even sure why it's there, but probably returning. But anyway, once you do that, you actually need to call that script. Okay, so we actually have the next speaker. We need to move on, but let me just finish up on this. Okay, so basically this is very easy. You go to this address, which is an Excel file. You go and find it and see what's there, download it, try it out. This is the credits model, and then you say, oh, look, let's have the inputs be this command. The data is this, test ratio is 20%, learning whatever, all of the rest doesn't really matter, it's defaults, and then you call on it with the CPU cluster with everything. Okay, so very easy. And then you say ML client, which is something that was created somewhere before. I'm not seeing this there, so somewhere before we created this. You say ML client dot create or update that job. So the job is, oh yeah, the job is here. Here we go. This is the job. Okay, so this library ML client creates this, starts this job. Now the job uploads, and then there's a they will tell you what to do here. So there's a GIF or something that will tell you what to do. You jump into the respective ones, so you can actually click on this and jump into the respective ones and see the status of your machine learning training in a graphical way, which is very helpful. It says completed. There's no child jobs in this case. You might have some images like a confusion matrix. Okay, so 96 is good, 41 is bad, this one is terrible, and this one is terrible. So these, the main diagonal should be very big, the other ones should be very small. Not definitely the case. So something is wrong with the training, but it's just an idea. So the curve, the curve here. So the area under the curve is the things that are got correct. The wrong ones are this, but the ideal curve would move all of this up to that corner over there, so this fails drastically. Okay, not a very good idea. The quality of this is very bad, so it needs to be closer to that corner over there to be good. Okay, so there's also a recall curve, nothing special here, but you can see this, all of this was generated by Python. Okay, and you have all of these informations that might help you. Say area under the curve score 82. It's not bad, but it could be much better. Okay, and you might have some other metrics as well. So there's a lot of metrics going on here that you can check out. Okay, and you can calculate your own. If you're doing Python, you can calculate your own. There is a lot more, so you can see some of the codes. The code is already yours, so nothing special. But then all of the other ones, if you have extra libraries for explainers, interpreters, etc., or fairness, you can actually monitor all of this in the other places. Okay, so nothing wrong with that. Okay, so having said that, let's wrap this up and just show you, jumping into the next parts. So last but not least, you can create an endpoint. So to deploy this as a web service, all you have to do is to say, oh, create an endpoint, and you give it some definitions like how do you authenticate it. It can be anonymous. Okay, in this case you have some sort of key, but in this case it's not special. But then in the end you say ML client dot create or update that endpoint, which is the variable, and then you get the result into that endpoint variable, which you might need to call it, and then it will show up here on the this endpoints one. So I don't have it here because there was an option here, and please be careful, don't run all of this at the same time. There's an option at the end of this that says kill the web service, okay? So don't do that last one if you want to play around with it. Okay, so in the end, it generates this, and then you can actually deploy it. So the deployment has been kind of done. Expect to take 6-7 minutes. So this is the deployment part itself, but then you can test it. You can actually go to have a JSON file with inputs and test this out, or try it yourself in that graphical environment similar to the ones that I've shown you for the other one in the beginning of the session. So you can try it out, and then in this case the result of all of these values, so you have 2 values of data, 2 records of data, all of these word values, in the end they give you 0 or 1. Not sure what this means. I'll have to look at the data in the Excel, but this one gets a 1, the next one gets a 0. We're happy with that, okay? In the end, it does the bad thing, so you can go here and comment it if you want to. You can go and raise a comment with a hash and make sure that the endpoint is not deleted, but remember this costs money. So the next job is you can go here to the endpoints and actually go here and delete them, okay? So I'm not going to do that now, but you can definitely go here and delete them. I'll delete them after the session is over, okay? So you can delete them from here so it doesn't spend your money, okay? If things are stopped, most of them will not spend money just to finish. So endpoints will cost you money, so turn them off, kill them if you can. Compute will cost you money, so the compute instance needs to be turned off. I'm going to do that now, so stop, very easy, okay? However, the compute clusters, because they are clusters and they have load balancers to jump into places, etc., they will also cost money, okay? So that will cost you a constant money per month, okay? So the idea here is that if you're not using the cluster, maybe a good idea to turn it off, because recently they started to charge for empty clusters, okay? So turn it off and then recreate it in code, which is very easy as well, okay? We've seen how to do that. And inside of your code, you can actually add a line similar to the other one that turns off the actual cluster, okay? So having said that, and I think I ran out of time, I exceeded a bit of my time. Apologies to the next speaker, but any questions that anyone has? So what are the steps to execute or build cluster model? So I'm not sure if I understand the question, just to answer the questions. Okay, so when you have the cluster, okay, you can actually create a cluster. So plus sign, I think that's the question you ask. So location all around the world, dedicated or low priority. So low priority is much cheaper, but there's a risk it turns off. GPU is much faster, okay? So you have hardware GPUs on your computers that will make it faster. The costs, you can select all options and start with the cheapest costs. Start with 8 cents per hour, something like that. But be careful, it only has 1 core, so it probably doesn't run everything you want, and 3.5 gigabytes of RAM. So you want to start with maybe at least 2 cores, 7 gigabytes of RAM, something like this, okay? But within the same price range, you actually have like 4 cores, 8 gigabytes, which is pretty much the same as this one. So choose, or this one, for instance, 14. This is good. This is reasonable here. Okay, one of these two is reasonable. So choose one that in terms of cost is reasonable. But yeah, remember that in the end, if you have twice as much cores, if you're running this as clusters, it will run twice as faster. So, you know, in the end, you know, if you run a training that takes 2 minutes, it doesn't, you're going to pay more for a more expensive machine. If your training takes 1 hour, it stops being 1 hour, starts being half an hour. So it's going to be faster. So in the end, if it is a big training, you know, there was no difference between them, more price, faster speed. So in the end, you pay almost the same. Okay. So I think that was the question. So you can choose the VMs you want. Okay. Give me a second. Oh, there's too many of them. Wait a minute. There's too many of these. So recommended options, and then you click on next. And then you specify minimum and maximum, okay? If you specify too much, the subscription will say you cannot use it. It's a limitation. You can request increase, but it has to be a paid subscription, okay? Idle seconds before turning off, some tags for, let's say, cost management, something like that. Okay, you can even enable SSL, SSH access, and a lot more things. So all of this is entirely up to you. Okay, so you can add all this, and then you click on the create button that's not listed here, and it just runs. Okay, so the other question is, if my data is kept on an on-prem service, can you connect to it using running a notebook? You can literally run some of these things on premises as well, and just send the results to the cloud, to the environment. That's perfectly possible. Or you can do simple things like getting getting a VPN or getting something called a data management gateway or a data gateway to get the data from on-premises onto the cloud. You can run everything on-premises if you really want to. There is no limitation here. You can run it on a different cloud, not Azure, okay? So there's no limitation. It's fairly easy, okay? Last question. What will be popular language for writing custom scripts? So Python has been, popular, okay? But R used to be popular. With C# you can still run machine learning with ML.NET. With Java and JavaScript, there are, a lot of different libraries like TensorFlow and a few others that have all of these options available. You can even run machine learning on the client side in a web browser, but, don't do that. It's just bad. Okay, so finishing up. Thank you all very much for being in the session. This is session number 5 of a series of sessions. And yes, again, thank you very much. Last but not least, just be careful, because if a computer tries to take the Turing tests and instead of actually, some of them might pass, and this might be interesting, but the worst part is if they can pass it and they intentionally fail it. That means that they're more intelligent than we are, and we have to be careful, because within some limited amount of time we'll all be enslaved by all of Skynets. Okay, so be careful. Anyway, thank you all very much. Let's move on to the next speaker. Okay, thank you all very much for being here. Okay, thank you for the questions.
Thank you very much. And I want to share one thing, that we have Andrew has Andrew has taken several sessions on machine learning, and if you want to learn, or if you want to jumpstart onto the machine learning area, you can follow his sessions. Those are on the YouTube, and anytime in your suitable, you can just click and see his earlier recording. So thank you very much, Andrew, for your nice presentation. And
thank you for having me here.
Thank you very much.
Thank you very much.
Thank you also for making a series of presentation on machine learning, and it will be very much helpful for the professionals.